Welcome back, students. Today let's solve remaining questions of exercise 1.1. In the previous class I have finished up to question number 4. Now question number 5. Name the property under multiplication used in each of the following. Here in this question we have to name the property under multiplication. Let us observe these questions. Roman number 1. Minus 4 by 5 into 1 is equal to 1 into minus 4 by 5 is equal to minus 4 by 5. Here 1 is using minus 4 by 5 multiplied by 1. So 1 is using. So this property, if we remind, here the property using is multiplicative identity. In this multiplicative identity, 2 by 7 into 1 is equal to 2 by 7. Here multiplying by 1. So actually this one is called 1 is the multiplicative identity. So here minus 4 by 5 into 1 is equal to 1 into minus 4 by 5 is equal to minus 4 by 5. Since the given rational number is multiplied by 1, so here the property using is one is the multiplicative identity. In Roman number 2, minus 13 by 17 into minus 2 by 7 is equal to minus 2 by 7 into minus 13 by 17. When we observe this question, here these two rational numbers, the order are changing, and in this case it is multiplying again. So this property is commutative of multiplication. So here you see multiplication is commutative for rational numbers. A into B is equal to B into A. Here the order of A and B are interchange. In the same way, here these two rational numbers, their order are interchange. So this property is called commutativity. Commutativity. Now Roman number 3, minus 19 by 27 into minus 29 by minus 19 is equal to 1. If we remind the multiplicative inverse or reciprocal property, here we see that 2 by 7 into 7 by 2 is equal to 1. So in this case, this 7 by 2 is called multiplicative inverse of 2 by 7. So when we multiply, if the answer is 1, then this property is multiplicative inverse or reciprocal. So this property is multiplicative inverse. Multiplicative inverse. Understand or not? Next question is question number 6. Multiply 6 by 13 by the reciprocal of minus 7 by 16. Here in this question, the question says that 6 by 13 will be multiplied by the reciprocal of minus 7 by 16. Now solution. First we have to find out the reciprocal of minus 7 by 16. The reciprocal of minus 7 by 16 is equal to, if we want to find out the reciprocal of a number, numerator and denominator are interchanged, then we are getting 16 by minus 7. Now take this number 6 by 13 and we have to multiply by the reciprocal, that means 16 by minus 7. 6 into 16, that is 96. 13 into minus 7, that is minus 91. Minus, we are not used to keep in the denominator, so let's keep in the numerator. Then the answer is minus 19 by 6, minus 96 by 91. I hope you can understand this. Question number 7 is homework. Now question number 8. Is 8 by 9 the multiplicative inverse of minus 1 whole number 1 by 8? Why or why not? Here it is asking that 8 by 9 is a multiplicative inverse of minus 1 whole number 1 by 8. And why or why not? Now solution. Let's remind multiplicative inverse. If a number and its multiplicative inverse are multiplied, then the answer must be 1. So to note that this 8 by 9 is the reciprocal of this given number, if we multiply these two numbers, let us calculate here. Eight by 9, if we multiply by this given number, minus 1 whole number 1 by 8 is equal to 8 by 9 into 8 one time is 8 plus 1 is 9 minus 9 by 8. 8 are cancelled, 9 divided 9 1 times. Here is my sign, so we are getting minus 1. And we see that this is not 1, this is minus 1. So 8 by 9 is not the multiplicative inverse of minus 1 whole number 1 by 8. 8 by 9 is not the multiplicative inverse of minus 1 whole number 1 by 8, because 8 by 9 into minus 1 whole number 1 by 8 is equal to 8 by 9 into 8 one time is 8 plus 1 is 9, so minus 9 by 8. 8 are cancelled, 9 divide 9 1 times. When 8 divide 8, we will get 1. 1 times 1 is 1. So minus 1 is getting. Is not equal to 1. Here it is over. Next, question number 9. Is 0.3 the multiplicative inverse of 3 whole number 1 by 3? Why or why not? Now solution. If we want to note that 0.3 is multiplicative inverse of 3 whole number 1 by 3, if we multiply these two numbers, if the answer is 1, then 0.3 is multiplicative inverse. Now let's calculate and let's see. 0.3 multiplied by this number, 3 whole number 1 by 3. 0.3, if we leave this decimal point, then 3 by 10 into 3 whole number 1 by 3, let's keep in 3 into 3 is 9 plus 1 is 10, 10 by 3, this is improper fraction. Then 3 divide 3 1 times, 10 divide 10 1 times 1 into 1 is 1. Since this is 1, this 0.3 is the multiplicative inverse of 3 whole number 1 by 3. 0.3 is the multiplicative inverse of 3 whole number 1 by 3. Because 0.3 into 3 whole number 1 by 3 is equal to, we are leaving this decimal point, then 3 by 10, 3 whole number 1 by 3, 3 times 3 is 9 plus 1 is 10, 10 by 3, 3 divide 3 1 times, 10 divide 10 1 times 1 is 1. So 0.3 is the multiplicative inverse of 3 whole number 1 by 3. Question number 10. Write Roman number 1, the rational number that does not have a reciprocal. Let us consider the number 0. For this number 0, if we want to write its reciprocal, this number 0 in the denominator there is 1. If we want to write its reciprocal, numerator and denominator are interchanged, then 1 by 0 is getting 1 by 0 is undefined because 0 cannot divide this one. This is undefined. So number 0 does not have its reciprocal. The rational number that does not have a reciprocal is 0. Roman number 2, the rational numbers that are equal to their reciprocals. Let us consider the numbers 1 and minus 1. 1, if we multiply by 1, then we are getting 1. And minus 1, if we multiply by the same number minus 1, again we are getting 1. So for this number 1, its reciprocal and this number 1 are equal. And for this minus 1 also, its reciprocal is minus 1. So the rational number that are equal to their reciprocal are 1 and minus 1. Roman number 3, the rational number that is equal to its negative. We see that for the number 0, and if we take its negative, that is minus 0. Since 0 have no value, we know that 0 and minus 0 are equal. So the rational number that is equal to its negative is 0. Students, for today, let's stop here. In the next class, let's do number line.